Evening. Continuation of the previous session. We were discussing on equalizers. What an equalizer is, for what it is. It is used to eliminate the interference, ISI interference, and also to reduce the additive noise as much as possible. Right? So here today we are going to discuss on different types of equalizers. This is the block diagram of adaptive equalizer. The equalizer is always placed in the receiver end so that we know the noise gets added during the path of transmission. Obviously, it has to be removed off or filtered only at the receiver end. So as to accomplish the process, equalizer has been placed at the receiver end. So the block diagram simply reflects the received signal which has been received by the filter, the receiver. Then this is the adaptive transversal equalizer from where the additive noise can be removed off, and finally it has been taken to the next stage. There are many modes of adaptive equalizers. Two important nodes are decision directed mode and decision directed equalizer. So this means that the receiver decisions are used to generate the error signal, and the next one is to offer adjustment which is effective in tracking slow variations in the channel response. However, this approach is not effective during initial acquisition process. And another mode is training mode to make the equalizer suitable in the initial acquisition duration. A training signal is needed. In this mode of operation, the transmitter generates a data symbol sequence known to the receiver. The receiver therefore substitutes this known data sequence in the place of the slicer output. Once an agreed time has elapsed, the slicer output is substituted and the actual data transmission begins. The two operating modes of the equalizer is training mode and tracking mode. Training mode, initially a known or fixed length of a training sequence or a data sequence is sent by the transmitter so that the receiver equalizer may average to a proper setting, and the training sequence is a pseudo random sequence or a signal or a fixed or a prescribed bit pattern. Immediately following the training sequence, the exact data or the user data is sent. This is the training mode. In tracking mode, when the data of the users are received, the adaptive algorithm of the equalizer tracks the changing channel. As a result of this, the adaptive equalizer continuously changes the filter characteristics over time to time. Equalizers are widely used in time division multiple access systems. This is the block diagram of adaptive equalizer, detailed drawing. So the original signal which has been modulated using the modulator and is then transmitted to the transmitter where it being sent to the radio channel, and also it has been given to the receiver front end, and IF stage is being added, and finally to the filter. And next, in the receiving end, after the equalization process is over, the decision maker output is summed up with the algorithm and the reconstructed original signal has been achieved at the receiver end. A generic adaptive equalizer. This is a traversal filter with many number of delay elements and n plus 1 taps and n plus 1 tunable complex weights. These weights are updated continuously by an adaptive algorithm so as to balance the equalization signals. Algorithms for adaptive equalization. This is many algorithms have been used based on the rate of convergence, misadjustment, computational complexity, and numerical properties. Many factors dominate the choice of equalization structure. One is cost, power budget, and radio propagation characteristics. Three classic equalizer algorithm: zero forcing algorithm, least mean square algorithm, recursive least squares algorithm. These are the dominating algorithms. And nonlinear equalization. Here, decision feedback equalization, maximum likelihood symbol deduction, maximum likelihood symbol sequence estimator. And this is the pictorial representation of every analyzer or equalizer, adaptive equalizer, decision feedback equalizer, and predictive decision feedback equalizer. And next is maximum likelihood equalizer. So this equalizer have a matched filter with the delay factors and also the channel estimator. This requires the knowledge of the channel characteristics in order to compute the matrix for making decisions. This also require knowledge of the statistical distribution of the noise corrupting the signal. This is the predictive decision feedback amplifier structure. Hope you have understood the types of equalizers and it is major significance. Thank you.